This is Mathdoctor, and let's begin with the Lagrange's mean value theorem. Much time in the history of mathematics, we know how to calculate the average of any given numbers. We just add them up and divide by the number of terms we have taken. This problem cannot be solved if we look at the graph of a function easily. Here we have to use the mean value theorems. So there are two mean value theorems, Lagrange's mean value theorem and the Cauchy's mean value theorem. We're going to look in this lecture about the Lagrange's mean value theorem. So mean value theorem indicates us about the rate of change of the function of a graph towards its derivative. So now let's begin with the
Lagrange's mean value theorem. So if a function is such that it is continuous in interval a b and it is differentiable in open interval a comma b, then there exists one value c in the open interval a comma b such that f of b minus f of a is upon b minus a should be the derivative of that function at that particular point c in the interval lies in the interval a comma b. So we will understand this with the help of geometrical function. Now let's begin with the geometrical interpretation of the Lagrange's mean value theorem. So this is the graph and this is slope, and these are the a comma b points, and a implies a comma f of a and b implies b comma f of b. Then the slope of the chord AB should be equals to f of b minus f of a upon b minus a using point slope formula. So since fx is continuous in the interval a and b, so its graph should be continuous from a to b, and since fx is derivable in the interval a and b, it possesses a unique tangent at every point between a and b. So if we talk about there should be one tangent which should be parallel to the chord AB. If abscissa of this point, then slope of the tangent there at is should be f dash c. So if c is the point, any point where tangent is parallel to the chord AB, then slope of the chord AB, then it must be written as like f dash c, where c is any point of we are going to find the tangent or slope. So as both have same slope, so we can write f dash c should be equal to fv upon is equals to the slope of AB, which is fv minus fa upon b minus a, which is equals to f dash c. So this is what Lagrange's mean value theorem tells us. So it implies that there is one point c whose tangent should be parallel to the chord AB, where we have to find the intervals AB, where we have to find the our Lagrange's mean value theorem, where we have to apply the Lagrange's mean value theorem in that particular interval, which are points of that particular A and B points. Now let's begin with the proof of Lagrange's mean value theorem, and further we will discuss some numerical problems. And now let's begin with the proof. Consider the function f of x with fx plus ax, where a is a constant to be determined such that, and we have applied the condition that if f of a is equals to f of b, then we can write f of a equals to small fa plus aa, and where a is a constant, and simply f of b should be small fb plus ab. Now we're going to just equating both these, and we will find that minus a should be equals to fb minus fa upon b minus a. So b minus a is the length of the interval, so this cannot be 0, otherwise there is no sense of any graph between same points. If b is equals to a, then it doesn't make any kind of sense for applying the mean of the graph. So now fx is given to the continuous in interval a and b and derivable in a and b. So also being a is being a constant, ax is also continuous. Therefore fx is equals to fx plus ax, if fx is small fx is also continuous and derivable, and ax is a continuous because it is polynomial function and it must be derivable too. And we have applied another condition, that is f of a and f of b, which we let in the start of the proof. So using these three conditions, fx satisfies all the properties of the Rolle's theorem, which we have discussed in the earlier classes. So there must exist at least one value in the open interval a and b such that f dash c should be equal to 0. So f dash c, we know that it is equals to f dash x plus a. So f dash c plus a should be equals to 0. So because c lies between interval a and b, and this should be equals to the third equation. We will now equating third equation and second equation. Minus a is equal to fb minus fa upon b minus a, and this particular f dash c, we will get Rolle's theorem. So this is all about the we will get the Lagrange's mean value theorem. So mean value theorems allows us to find the mean or average between the graphs. So that's the idea. Let's solve some examples. Now verify mean value theorem and find c if possible. So and that using Lagrange's mean value theorem, we actually find the mean of the where we find the mean, such that the slope of the chord and the that particular point should be same. So let's find the c, what point we will get. So let's open fx. First of all, it should be x cube minus 3x square plus 2x, and we will find the between interval 0 and 1 by 2. Now we will discuss about f of 0, which is a, will become f of a equals to 0, and f of b is 1 by 2 into 1 by 2 minus 1 into 1 by 2 minus 2, and it is equal to 1 by 2 into minus 1 by 2, and 1 by 2 minus 2 is minus 3 by 2. So we will get 1 by 2 into 3 by 4 is equal to 3 by 8. So as we know, a is equals to 0 and b is equals to 1 by 2. So fx being a polynomial is continuous. We know if it is a polynomial given, it should be continuous and derivable. So using mean value theorem, so its derivation exists. We will find the derivation by derivable by just making the derivative of this particular function. And by mean value theorem, we have f dash c equals to fv minus fa upon b minus a, which is equals to f dash c is equals to 3c square minus 6c plus 2, which is equals to fb is 3 by 8 minus 0 upon 1 by 2 minus 0. So it should be equals to 3c square minus 6c plus 2, which is equal to 3 by 4, and it will be equals to 4 will go here, 12c square minus 24c plus 8 equals to 3. Now we will find the value of c in the using Sridharacharya formula, and also known as quadratic formula. So we will find this easily. So using calculator, we will find that 1.75 does not lie between intervals a and b. So c does not exist. The value of c 1.76 does not exist between 0 and 1 by 2. So c equals to 0.24 is the only value of c that lies between 0 and 1 by 2. So that's the first, and now let's discuss about the second one, b part. So fx can be written as x cube minus 6x square plus 11x minus c in interval 0 and 4. So a is 0 and b is 4. F of 0 should be equals to minus x, and f of 4 should be equals to 4 cube minus 6 4 square plus 11 4 minus 6, which is 64 minus 96 plus 38. So that should be, we will get 6 as an answer. So fx being a polynomial is continuous in the interval, and f test x, which we will find at 3x square minus 12x plus 11 by using by using our own derivable of fx. So by mean value theorems, we have fb minus fa upon b minus a should be equals to f dash c. So f dash c is 3c square minus 12c plus 11, and fp is 6 minus 6 a is minus 6, f of a is minus 6, so it should be upon 4 minus a, 4 minus 0, it should be equals to 12 upon 4. So 3 equals to 3c square, and that is how we will find 3c square minus 12c plus 8. So we can, using quadratic formula, we will get c as 3.55 and 0.845 lies in the interval 0 and 4. So now let's discuss the second one. Show that if x is greater than 0, log 1 plus x is greater than x upon 1 plus x. Now let fx is log 1 plus x minus x upon 1 plus x. So taking the derivative of the function, given function, we will now notice that it arrives at which is positive if x is greater than 0, then derivative should always be positive. So it is implied that fx is monotonically increasing function. If it is monotonically increasing function, then fx should be greater than f of 0. So because x is always greater than 0, so by increasing the value of x, fx should always comes with higher value. So because it is monotonically increasing function, we have, if f of 0 should be less than f of x, because x is always greater than 0. So f of 0 is 0 and f of x should always be greater than 0. So f of x, we have given that here log 1 plus x minus x upon 1 plus x. So this is how we get our answer, log 1 plus x. By making x upon 1 plus x right side, we will get our answer. So that's the idea. Hence we prove this equation using Lagrange's mean value theorem. So Lagrange's mean value theorem we use here just to know that it is monotonically increasing function or not. First of all, we will do its derivation, derivable. It is always differentiable, so then we will find easily that it should always be greater than 0. So that's the idea. You can prove it anyway. So I hope you enjoy my lecture. Keep learning, keep sharing with your friends, and keep exploring. So share with #Mathdoctor. Thank you all. See you next video.